We're going to talk about the heavens declare the glory of God this morning. And my prayer, my hope is that when we're done here in the next less than 30 minutes, you will have a better appreciation for the glory of God than when we started. We are literally going to magnify God as we look at what he has done. But I want to start actually with a story, a true story, that all takes place April 11th, 1970 at 2:13 p.m. Eastern Standard Time. Does anyone know the significance of that date? Who said when I was born? I am offended, sir. I was born in 1983. Do not let the hair fool you, okay? We're no longer friends. I'm just going to talk to this side of the room now. You know, someone always says that. It's not when I was born. All right. This actually is an important date. Has to do with astronomy. Actually has to do with the launch of the Apollo 13 spacecraft. You see, on April 11, 1970, at 2:13 p.m. Eastern Standard Time, the Apollo 13 spacecraft was launched from the Kennedy Space Center. This was the third scheduled mission to the moon. Now, unfortunately, as many of you are probably aware, Apollo 13 never landed on the moon. You see, everything was going to plan on this magnificently designed spacecraft. However, 55 hours and 54 minutes into the mission, traveling at 2,000 miles per hour, the crew feels and experiences an explosion. And then you get Captain Jack Swigert famous words. Do you guys know them? Houston, we have a problem. You're thinking, Jack Swigert, wasn't that Tom Hanks? I know some of you are thinking that. It wasn't Tom Hanks. And it was a huge problem. You see, one of the oxygen tanks had exploded, leaking into space. And two of the three fuel cells that actually power the electronics on the spacecraft are now dead, and the third is rapidly depleting. The Apollo 13 space crew has a new mission, and that is to make it home safely. Despite limited power, loss of lack of drinking water, temperature issues. I mean, there was huge problems. Oxygen, a carbon dioxide problem. They actually did return home on April 17th, so 6 days later. And this mission was called a successful failure. A successful failure. Now, why am I telling you about this mission? Well, just as the astronauts survive against all odds in the lethal conditions of space, we too survive against all odds on this tiny planet we call Earth. You see, the conditions of the spacecraft are finely tuned to support life, the life of the three astronauts. And the slightest change in these conditions put the astronauts' lives in jeopardy. In the same way, the conditions of the Earth and our solar system and our galaxy and the universe are finely tuned for life, our survival. And the slightest change in these conditions puts our lives in danger. And so this, in philosophy, we call these conditions finely tuned. And this fine tuning can be described as, think of a tightrope walker walking across a tightrope stretched across two skyscrapers, okay? Literally, on either side of the tightrope, we would say it does not support life, right? I mean, if you take one step to the left or one step to the right, those conditions don't support life. In the same way, there are conditions that must be just so on the Earth and the universe and so on, and if you go one way or the other, there can be no life, or life becomes highly improbable. So what I'd like to do is I want to start with the Earth, and I want to look at the Earth, and then I want to go up from the Earth, look at our solar system, and then I want to go from our solar system, I want to look at our galaxy, and then finally I want to finish by talking about the structure of the universe. How does that sound? Great, 4 of you are excited about that. All right. let's start with the Earth. Now, for life to exist on our planet, we need an atmosphere. And not only do we need an atmosphere, we need just the right atmosphere. For example, Uranus contains deadly gases. I knew there'd be one person. There's always one. This is science here, people. This is science. Let's get serious. Let's get serious. Some of you are a little slower and are just catching on now. Look, I taught grade 9, and I could not get away with saying that to a class of grade 9 students. All right, but it's true. It's the wrong atmosphere. You couldn't live there, and primarily because its atmosphere is made up of helium and methane and hydrogen. You couldn't survive there. You can survive on our planet. Well, why is that? Well, because we have the right gases. In particular, we have the right amount of oxygen. It turns out that if you were to change the amount of oxygen, higher order mammals like ourselves would not be able to survive. Do you guys know that what percentage of oxygen you're breathing in as I'm speaking? 21, very good, 21%. What happens when you mess with these numbers? Well, if you were to crank that down to 10%, everyone in this room suffocates. That's not good. What happens if you crank it up? Well, if you crank it up to 30%, that makes life highly improbable because you just light a match and fires are breaking out and hard to control. Okay? So that's not good either. But I want you to say, Tim, I'm not impressed by that. Say, Tim, I'm not impressed by that. You're not impressed by that. This is just to give you a flavor of what fine-tuning is like, but it's going to get much more finely tuned as we go. Have you guys heard of Goldilocks and the Three Bears? Right? One porridge is too hot, one's too cold, one's just right. Well, in astronomy, there's something called the Goldilocks Principle, okay? And what they've done is they've applied this idea to our proximity to our planetary star, which we call some of you are listening, the sun, right? We're just at the right distance. It turns out our planet is at just the right distance to support life, and they call this the Goldilocks Principle. For example, if you were to go further out, let's say Earth is a little bit further out from the sun, not even out to where Mars is, but kind of in that direction, it becomes impossible for life to exist. And that's because, well, we're going to talk about that. It's too cold. Too cold for a certain property we'll come back to. If you get too close, it's too hot. For example, Venus is 700 degrees Fahrenheit at the surface, okay? It's too hot. Where we reside, it's called the habitable zone, a life zone, okay? Not too hot, not too cold, but just right. Now, the temperature is important, but that's not the biggest issue. The temperature relates to whether or not you can get liquid water. Okay, this is the important part. You see, if you get too far out, all you have is solid water, which we call ice, okay? If you go and so on Mars, we think we have evidence for maybe a lake or something that was there, but it's totally frozen, okay? Mars at its equator, in the middle of summer, is just a few degrees above 0. All right, so it's very, very cold there. You go too close, like Venus, well, it's too hot. You could never get liquid water. You could get water vapor. Now, Venus is almost entirely carbon dioxide, so, but in theory, you could get water vapor. If you've been to Earth, and it is beautiful this time of year. Any of you guys been? It has all 3 states of water, solid, liquid, and gas. Now, what you're looking at is truly amazing. So we'll zoom in here. Now, our Earth is about 70% covered in water, and that's just on the surface. There's actually more water kind of under the surface, and that's kind of cool. But you need the right amount of water. You need an abundance of it. You need an active water cycle. That's important. Water has all these cool properties about its heat capacity. Like, why is it that when you're walking on the beach and your feet are just like cooking, and then you put them in the water, and it's like, oh, it's so nice, right? And it has to do with how it holds heat and this kind of thing. But what's really cool about water is actually has to do with what you're looking at. You see, every natural occurring substance that we know of, except for water, when it goes from its liquid form to its solid form, does it get more dense or less dense? gets more dense. This is particle theory. Learn this early on, you know. Oh, you're going to freeze, all the particles get closer together, more dense. Well, it turns out, because of water's molecular structure, when it goes from its liquid to solid form, it actually gets less dense, and it's why that giant ice cube is floating, right? It turns out, if water was like every other natural occurring substance, then those icebergs and so on would sink to the bottom of oceans and lakes and kill all marine life, and would freeze from the bottom up, first killing all marine life and then eventually killing all of life. Literally, we should thank God that he has designed water the way he has. Now, you can try this at home, by the way. If you take a glass and then fill it with water and then dump some ice cubes in, if they don't float, you did something wrong, okay? You can actually taste the fine tuning. It's really, really good. I just want to take a drink, so that's a good segue. All right, let's go. Say, Tim, I'm not impressed by that. You guys are not easily impressed. How about this? Did you guys know the earth is tilted? You probably realized that when you walked in, you're like, whoa. No, you didn't do that. No, but the earth is tilted. If it wasn't tilted, the equator and the poles would be at extreme temperatures. Now, they already get pretty extreme, but they'd be even more extreme. Essentially, the equator would be cooked. The poles would be absolutely frozen, okay? But the earth is tilted, and this is what kind of regulates our seasons. And this is a beautiful season we have right now, right? And so it's tilted at 23.5 degrees. Now, what's actually holding that tilt has to do with our close little neighbor, the moon. Now, a large moon is important for our survival. It's actually regulating this tilt that we have, okay? Without the moon, in fact, this is contemporary science right here. If the moon didn't exist, you wouldn't either, okay? If the moon didn't exist, you wouldn't either. And it's actually quite rare to find a large moon next to a planet like ours when we search out throughout the heavens. The moon is about a quarter the size of the earth. But I know you're not impressed by that either. So let me give you another. Do you guys know that there is a giant bar magnet in the center of the earth? Well, it's not really a bar magnet, but it acts like that. It's a liquid iron core. It does the same idea. It generates a magnetic field. Now, this is important because there's a liability of being so close to the sun. You see, you gotta be in the Goldilocks zone. You gotta be at that distance. But the problem is the sun is bombarding the earth with deadly cosmic particles and radiation. Not good. It should obliterate all of life on our planet. But it doesn't. Well, why not? Well, because our magnetic field acts like a shield, protecting the earth from all these particles and radiation. In fact, when the particles come in, they actually get deflected by the magnetic field and forced to the poles. Now, this is kind of cool, because has anyone seen the Northern Lights before? It's kind of cool. The Northern Lights, go on there, Google it. It's a really cool light show. But what you're watching has to do with what we're talking about. The particles are deflected to the poles, interact with the atmosphere, the gases at those poles, and puts on this light show. So not only are you watching something that is absolutely magnificent to just behold, but next time you see the Northern Lights, think, that's helping me stay alive, okay? Kind of cool, but you're not impressed by that either. So let's go from the Earth and look at the solar system. How many people remember when there was 9 planets? Yeah, those were the days, right? When I was in school, it wasn't that long ago, 1970. When I was in school, and there was 9 planets. But you guys heard what happened to Pluto, right? Pluto got demoted. Pluto's now a dwarf planet, okay? Now, does anyone know why Pluto got demoted? Someone say it's too small. It's not because it's too small. I just like getting the wrong answer, because then I feel like I'm teaching you something. Okay, so teachers love that kind of thing. It's not because it's too small. A lot of people think that. It actually has to do with its orbit. You see, it was discovered not that long ago that Pluto's orbit actually is highly elliptical and crosses over Neptune's orbit, which is right next to it, okay? And I don't know who gets to make this call, but if you don't have your own orbit, you can't be a planet, okay? I want that kind of power, you know? Who makes that? Actually, there's a debate on YouTube. It's like 3 hours long over whether Pluto should be a planet or not. It's absolutely riveting, okay? So you should, if you're having trouble sleeping tonight, check that out. Now, I want you to imagine that there's an asteroid. Actually, everyone together now. Oh no, it's an asteroid. Wow, I sense the fear. Wow, this is like an Armageddon situation. It's an asteroid headed straight for us. Now, you guys aren't too worried about that. There's a reason for it. We actually have these gas giants that are in the outer part of our solar system. So you got the 4 terrestrial planets, the rocky planets, and then you have the 4 gas giants. Now, this is important. These gas giants help keep us alive. What happens is they end up pulling in, because they're so large, they end up pulling in all kinds of space debris towards them, in particular, Jupiter. I actually taught in the public school system for a couple of years, and in the Christian school system. And in the public school textbook, when we taught astronomy, we taught about the solar system, it actually said, Jupiter is a cosmic vacuum cleaner. If Jupiter didn't exist, you wouldn't either. And that's the consensus science. Because it turns out Jupiter, which is absolutely, I mean, this is not to scale. The spot, this red spot on Jupiter is like 2 times the size of the Earth. It's just, that's a hurricane that's been going on for a couple hundred years, okay? That's a big storm, all right? You could fit 1,300 Earths inside Jupiter. Its magnetic field is so strong that it's constantly pulling in asteroids and all kinds of space debris that gets kicked into our solar system. And so quite literally, I don't have the animation here, but I show it crashing into the planet. It's kind of spectacular. But quite literally, we should thank God for Jupiter. In fact, when I have 3 little girls, so you need to pray for me, okay? And my 7-year-old, when she was, 4 or 5, she saw me do this presentation, and for months, every night, she would thank God for that big planet. You know, it's just so great, so great. Proud dad moment there. Let's go from the solar system to the galaxy. So not only is our Earth finely tuned for our survival, not only is our solar system, but so is our galaxy. You see, our galaxy is, it's a spiral galaxy. You can kind of see the spiral arms there. It has about 100 billion stars. I don't know who counted, okay? 100 billion stars. It's quite remarkable. Where we reside is actually in just the right location. Oh yeah, it's 100,000 light years across. Now, what's a light year? It's a distance measurement. The yardstick ain't gonna cut it, okay, if you're measuring a galaxy. So what they use is this measurement, how far does light go in 1 year? Well, light at a constant speed travels about 6 trillion miles in 1 year. And so you can do the math there. This is a very large object, okay? It turns out where we reside is just the right distance from the center and actually between the spiral arms to survive. You see, you don't want to be too close to the center of our galaxy because there's a massive black hole in the center of it and supergiant stars that are kicking out all kinds of radiation. We couldn't survive there. You don't want to be too far out in the galaxy because there are no heavy elements. Think of a periodic table, okay? Out there, I mean, if I was teaching chemistry, it'd be like, students, get out your periodic tables. Hydrogen, that'd be easy. There just isn't these heavy elements, oxygen, carbon, nitrogen, you go through the list, they're just not out there, okay? You have supernova going off, exploded stars. You don't want to be next to those when they go off. It turns out where we reside in our galaxy seems to be the right spot. Now, you're probably thinking, Tim, you're probably one of these creationists, and this is something you just have to say because you believe in God or something like that. Listen, this is not controversial, what we're talking about. The fact that the universe, the Earth, the soul, and so on is finely tuned. Now, many people deny a fine-tuner, come back to that, but the fact that it is fine-tuned, that there are these conditions, is pretty much accepted by everyone, okay? And that's why, just a couple years ago, Discover Magazine picked up this scientific paper, and they were reporting on it, and they said, the headline caught my attention, Earth may be a 1 in 700 quintillion kind of place. First of all, what is a quintillion? Well, they said 700 quintillion, that's a 7 followed by 20 zeros. That's how many planets they think, guesstimating really, how many are in the universe. Only one like Earth. Why would they say that? Why would they say there are 700 quintillion planets in the universe, but only one like Earth? Because of what we're talking about. Because of what we're talking about. There are these conditions that seem to be just right. And by the way, if you're at like a little social gathering and you want to sound smart, just say quintillion, okay? And you'll sound really, really smart. Now, I want you, so it seems like our Earth is one of a kind. It's special. Dare I say designed, okay? But I want you to forget everything I just told you. You're thinking, already done, right? I don't know what you're talking about. Now, they're recording this, all right? So you can rewatch it if you want to. I want you to forget everything I just told you because the real fine-tuning has to do with the structure of the universe, okay? Not just our planet, not just our solar system, not just our galaxy, but our planet. It turns out, I want you to imagine that there's a room inside our universe, and it has all these controls. So let's call it the universe control room, okay? It has all these dials, and the dials have to be set just right, and if you mess with the dials, you destroy the universe. You destroy any chance of there being a life-permitting universe, okay? You get a universe where there's no stars. There's no stars, there's not gonna be any life. You get a universe where there's no planets. You get a universe where there's no chemistry. These kinds of things. That is finely tuned for life. So think of it like a radio dial. How many people here have actually tuned a radio? Remember those? See, that's the old people in the room? Like before there was presets, right? And you had to like, oh, too far, bring it back. That kind of thing. That's what we're talking about. Fine tuning like that. These dials. And these dials are set to the life permitting spot. And if you change it just the smallest amount, you go from life permitting, allowing life, making it possible, to life prohibiting. There can't be any life. Okay, that's what we're talking about. Now, just to give you a sense of what the scientists are actually saying about this, I want to quote a couple guys to you. First, Freeman Dyson. And again, these guys aren't Christians, okay? Just here's a theoretical physicist, Freeman Dyson. He didn't invent the vacuum cleaner, okay? Now, some of you are thinking that. And I don't know why his pants are so high. He says this. The more I examine the universe and study the details of its architecture, the more evidence I find that the universe in some sense must have known that we were coming. That is a very curious statement. The more I study, the more evidence I find. Interesting. Okay, how about this one? You have Fred Hoyle, and he says, a common sense interpretation of the facts suggests that a super intellect has monkeyed with physics, as well as with chemistry and biology. I don't know how the monkeys always get into these creation discussions. He says, and there are no blind forces we're speaking about in nature. The numbers one calculates from the facts seems to me so overwhelming as to put this conclusion almost beyond question. How about this one? You have George Greenstein. He's an astronomer, and he says this. As we survey all the evidence, the thought insistently arises that some supernatural agency, or rather, and he puts the capital A, agency must be involved. Here's a couple questions he has. Is it possible that suddenly, without intending to, we have stumbled upon scientific proof for the existence of a supreme being? The answer is yes. Was it God who stepped in and so providentially crafted the cosmos for our benefit? The answer is so what are these guys talking about? What are they talking about? Well, let me just give you one dial. Remember all the dials in the universe control room? I'm going to talk about one of them because we all understand gravity. It's what's keeping your tushy. Can I say tushy in church? It's what's keeping your bottom in your seat right now. It's why you're not floating around the room. We all have experience with gravity, so you guys can understand this, I think. It turns out every two objects in the universe are gravitationally attracted to each other. So I'm attracted to the earth, that's why I'm staying on the ground. I'm attracted to the podium. I'm attracted to the Andromeda galaxy 2.5 million light years away. This is actually a pickup line I used on my wife. Do you guys want to hear about that? Or should I just move on? Okay, I was gonna talk about it anyways. So in university, my wife and I went to York University. It's just north of Toronto. And we met in the library. We were actually introduced to each other, and I was a bit of a clown. And so we got introduced, and I said to her, "Did you know you're attracted to me?" Now, I actually had hair back then, so I had a different thing going on. And she said, "Excuse me?" What? I said, "Yeah, well, gravitationally. Right? It's a physical attraction, right? Every two... Listen, I would... Guys, she married me, okay? So, for what that's worth. Yeah, so I was studying physics, she was studying chemistry, and by the way, there was chemistry. Well, it turns out, in that equation that we would teach high school students, this is, the force of gravity equation. This is called the gravity constant. Okay, so the two masses, every two objects, they both have mass, the distance between them, if you got those numbers, and then this constant. Well, it turns out that constant, which we don't get to play with, we don't want to touch that number. That's a number that was just that is the gravitational constant from the beginning of the universe. If you change that number, there's problems. In fact, scientists think it's finely tuned to 1 part in 10 to the 40th power. Well, what's that? That's a 1 followed by 40 zeros. In fact, just to give you a sense of what we're talking about, the odds of me being hit by lightning are about 1 in a million. The odds of me winning the lottery in Canada, it's a little bit easier there. We have less people. It's about 1 in 100 million, okay? The odds of me being struck by lightning, surviving, and then being struck by lightning again and surviving are 1 in a trillion. That's the orange you're looking at. The odds of us getting the gravitational constant that will allow for life is all the zeros. Okay, think of it like this. I want you to take dimes. What we're gonna do is take dimes and cut, those are Canadian dimes, by the way. That's why they have a sailboat on them. And we're going to, and they're not worth as much when I come here, by the way. Take those dimes and we're gonna cover the entire continent of North America. Say, that's a lot of dimes. It is a lot of dimes. I copied and pasted those on there, okay? And then what we're going to do is we're going to take those dimes covering the entire continent of North America and stack them all the way to the moon. Say, that's a lot of dimes. And by the way, that's why I gave up only doing that much, okay? Because it was too many dimes. And then what I want to do is I want us to do that on 1 billion more continents. From the ground to the moon. Say, that's a lot of dimes. Okay, so we have all those dimes covering the entire continent of North America, all the way to the moon, on 1 billion continents. And then I take 1 dime and I paint it red, and I throw it into the sea of dimes. And then I put a gun to your head and I say, pick the red one, blindfolded, or you're dead. Your odds are actually better that you would pick the life-permitting dime than getting the gravitational constant. That's what we're talking about here, okay? Just to give you a sense of these numbers. Or here's another analogy one theoretical physicist came up with. He said, take a tape measure, stretch it across the entire known universe, galaxy universe. There's 1 inch on that tape measure that is the life-permitting inch, okay? If you were picking an inch at random, there's 1 inch that's life-permitting. If you go one way or the other, there's no chance of life. This, by the way, Christopher Hitchens, the late Christopher Hitchens, who wrote a book called God is Not Great, How Religion Poisons Everything. In a debate, he said that the fine-tuning argument is the best argument that Christians have for the existence of God. I think he's right. I think there's a lot of good arguments, but this is one of the best arguments. It is overwhelming. We've only scratched the surface. We could keep going on and on and on with all these examples. And eventually, I think if we're honest, you start to say, yeah, this starts to sound like it's a setup. Like someone designed this. In fact, if you picked the red dime in our last illustration, everyone in the room would say, hey, you peaked. No one would think that you picked that red dime by chance. We just wouldn't. We'd all say, you peaked. Do it again. I'm watching you this time. You know, that kind of thing. You designed the outcome. We'd all conclude design. Some people, though, they say, no. As long as there's a chance possibility, I'll believe in chance over design. But that reminds me of a clip from Dumb and Dumber. And I'm not endorsing the movie here, but there's a very funny part of the movie where Lloyd Christmas, he ends up meeting this girl, Mary, in an airport, and the rest of the movie, he's going to find her. He drives across the country. He eventually comes face to face with Mary, and he asks her, what are the chances of you and me getting together, you know, being a couple? And let's play his response.
What are my chances?
Not good.
You mean not good like 1 out of 100?
I'd say more like 1 out of 1,000,000.
So you're telling me there's a chance?
All right.
Yeah!
No, see, Lloyd doesn't get it. He doesn't get it. It's not going to happen. That's what she's saying, right? And when we look at these numbers, and by the way, we just scratched the surface. I mean, the cosmological constant, which has to do with dark energy, and I don't want to get into all that, it's fine-tuned to 1 part in 10 to the 120th power. That, by the way, there's only 10 to the 80th power of subatomic particles in the whole universe. These numbers are beyond our comprehension. And so saying, well, so you're saying there's a chance. To me, that's ludicrous. That's ludicrous. It's no wonder that Robert Jastrow, he was an agnostic astronomer, but he wrote a book called God and the Astronomers. Listen to what he says. For the scientist who has lived by his faith in the power of reason, the story ends like a bad dream. He has scaled the mountains of ignorance. He's about to conquer the highest peak. And as he pulls himself over the final rock, he's greeted by a band of theologians who have been sitting there for centuries. Because what if theologians have been saying for centuries that 20th and 21st century scientists are just starting to say, oh yeah, that's the way it is. It's in the beginning God created the heavens and the earth, right? It's no wonder that David, the psalmist, said in Psalm 19 verse 1, the heavens declare the glory of God. The skies proclaim the work of his hands. He didn't know about all the stuff we're talking about. He knew enough though. He knew enough. He says, when I look at your heavens, the work of your fingers, the sun, the moon, and the stars, which you have set in place, what is man that you are mindful of him, the son of man that you care for him? Kind of this rhetorical question. But then he goes right to say, yet you made him a little lower than the heavenly beings and crowned him with glory and honor. He connects the mindfulness of man, God's mindfulness of man, with his making of man. Those things are connected. His designing of man and designing of the universe, the work of his fingers. Of course, David also says, for as high as the heavens are above the earth, so great is his love for those who revere him. How high are the heavens above the earth? I wish I had another half hour to talk about that. We don't even know how high they are. By the way, the universe is expanding as we speak. Like, it's grown since we started this, okay? And so how high are the heavens? And so God compares his love for you and I with the size of the heavens, the universe. Now, this isn't some distant, detached God. This is a personal God who loves you. How do I know that? Well, go to 1 John. We looked at Genesis 1, go to John 1, and he says, in the beginning was the Word, and the Word was with God, and the Word was God. And then he says, all things were made through him, the Word, and without him was not anything made that was made. So the Word made everything. Everything we just looked at, the Word made. And then it says, verse 14, the Word became flesh and dwelt among us. The creator, designer of everything we looked at took on flesh. Why would he do that? Well, to seek and to save that which was lost, because he loves you. We all know the verse, right? For God so loved the world that he gave his only son, that whoever believes in him should not perish but have eternal life. God came on a rescue mission. That to me is greater news than everything we just looked at, right? All these fine-tuned constants. God loved us enough to do that. Let's pray. God, we thank you for what you have done and how you have revealed yourself. We are truly without excuse. Your fingerprints are all over this creation. And so, God, I pray that for those Christians in the room, they would just be more in awe than ever of what you have done. The heavens declare your glory. And for those who maybe don't know you or are asking questions about you, I pray that you would use this kind of material to reveal yourself. Throughout the Bible, always pointing back. Look at what he's made. Look at what he's made. This is what he's like. And so, God, thank you for that revelation that we just get to look a sneak peek of. Just rivet this truth to our heart. Help us not to forget it, especially when we're sharing our faith with others. God, we thank you and we love you. In your name we pray. Amen.